take a look at the reaction between hydrogen and oxygen to form water. Just for review, the little 2's are called subscripts. The numbers in front of the elements and the compounds are called coefficients. So let's say we have the number 1 in front of each of these. The first step is to draw a particle picture, a representation of what this 1 means. So this is one set of hydrogen. This is one set of oxygen, and this is one set of water. Now we're going to compare the number of atoms of each reactant in each product. So we have hydrogen on the reactant side, and there's 1, 2 of them. And we also have oxygen on the reactant side, and there's 2 of them. On the product side, we have 2 hydrogens, 1, 2, and only 1 oxygen. So for an equation to be balanced, the number of each atom needs to be identical. And here you see it's not. So this equation is unbalanced. It's impossible. It seems we lost an oxygen. Let's go ahead and take a look at another reaction. Again, hydrogen is going to react with oxygen to form water. However, we're going to change the coefficients. We're going to put the number 2 in front of the hydrogen, a 1 in front of the oxygen, and a 2 in front of the water. Let's draw some particle pictures. Here we have 2 moles represented by 2 sets of hydrogen, 2 sets of H2, reacting with 1 set of O2 to produce 2 sets of H2O. And if you can't see it already, we're going to do an atom inventory. We're going to take a look at how much hydrogen's on the reactant side, 1, 2, 3, 4, and how many oxygen atoms are. There's 2. And then on the product side, we're going to do the same thing. There's 1, 2, 3, 4 hydrogens and 2 oxygens. And when you compare the atoms on the reactant side to the atoms on the product side, you realize they are the same. This is an example of a balanced chemical equations. The reactants rearrange to form products. Let's take a look at another example. This time, we're going to react nitrogen with hydrogen to form ammonia. The coefficients, let's keep it simple. Let's keep the coefficients all 1. Again, we'll start with particle pictures. We have 1 mole of nitrogen reacting, which we'll represent with 1 set of nitrogen, reacting with 1 set of hydrogen to produce 1 set of NH3 or ammonia. And if we do our atom inventory and compare the number of each type of element on the reactant and product side, we see we have 2 nitrogen and 2 hydrogen. And on the product side, we have 1 nitrogen and 3 hydrogen. And here you can see the numbers do not match up at all. This is in another example of an unbalanced chemical equation. Let's look at that reaction again, but this time the coefficients are going to be 1, 3, 2. So let's go ahead and draw our particle pictures. We have 1 mole of nitrogen reacting with 3 moles of hydrogen, and we represent that by drawing 1 set of nitrogen and 3 sets of hydrogen. 1, 2, 3. And on the product side, we're going to form 2 moles of NH3, or 2 sets of NH3. Let's go ahead and do our atom inventory on the reactant side to the left of the arrow. We have 2 atoms of nitrogen reacting with 6 atoms of hydrogen to form 2 atoms of nitrogen and 6 atoms of hydrogen. These numbers are the same, so this is an example of a balanced chemical reaction.